In this video, I would like to explain about Michaelis Menten equation. Leonor Michaelis and Mount L. Menten in 1913 proposed this theory, and this theory is based on many assumptions. They are: only a single substrate and a single product are involved. Only a single substrate and a single product are involved. The second one is the process proceeds essentially to completion. And the third one is the concentration of the substrate is much higher than that of the enzyme in the system. And the fourth one is an intermediate enzyme substrate complex is formed. Then the last one is rate of decomposition of the substrate is proportional to the concentration of the enzyme substrate complex. These are the 5 postulates behind this theory. These are the 5 assumptions behind this theory. This theory postulates that the enzyme E forms a weakly bonded complex, enzyme substrate complex with the substrate, and this enzyme substrate complex upon hydrolysis gives product and the free enzyme. The Michaelis and Menten experienced some difficulties in determining the concentration of the enzyme substrate complex and the substrate concentration, etc. So, they replaced the immeasurable quantities with those which could be easily measured experimentally. They are: ET is the total concentration of enzyme, S the total concentration of substrate, and ES concentration of enzyme substrate complex, and ET minus ES equals the concentration of free enzyme. ET is the total concentration of enzyme, S is the total concentration of substrate, ES is the concentration of enzyme substrate complex, and ET minus ES is the concentration of free enzyme. These are the symbols they used in deriving the equation. Now we can write the equation: E plus S gives ES, which on dissociation gives E plus P. P is the product. Now the rate of appearance of product, that is also known as velocity, is directly proportional to the enzyme substrate complex. The rate of appearance of product, that is velocity V, is proportional to concentration of the enzyme substrate complex. That we can write V directly proportional to ES. Now we can write in this way: V equals K into ES. Put this equation as 1. Now the maximum reaction rate is Vmax will occur at a point where the total enzyme concentration, total enzyme ET, bounds to the substrate. So the Vmax directly proportional to ET. That is, the maximum concentration of ES is equal to the total enzyme concentration. This we can write it as Vm equals K into ET. Put this equation as 2. Now divide equation 1 by 2. Divide equation 1 by 2. So we get V by Vm equals K into ES by K into ET. By cancelling these K's, we get ES by ET. This we can write it as equation 3. So with the help of this equation, we can easily measure the immeasurable quantities such as we can measure ES, ET, and in terms of the reaction rate experimentally. Now coming back to the reversible reaction, E plus S gives ES. We can write the equilibrium constant for the dissociation of ES as Km, which is equal to ET minus ES into S divided by ES. Here the dissociation constant Km equals concentration of the reactants divided by product. Concentration of the reactants divided by product. So we get concentration of E into concentration of S divided by ES. Instead of E, we can use ET minus ES. Instead of E, we can use ET minus ES. So the reaction is like this, ET minus ES into S divided by ES. That is Km is concentration of the reactants divided by concentration of the products. Here the reactants are E and S. So we can write Km equals E into S divided by concentration of the product is ES. For E, we have another equation, E equals ET minus ES. So put this here. Instead of E, we can use this ET minus ES into S divided by ES. We can use this equation as 4. Now we can cross multiply this. So we get Km into ES equal to ET minus ES into S. That is like this. That is like this, Km into ES equals ET minus ET into S minus ES into S. Here we can expand this here, ET into S, ET into S and minus ES into S, that is ES into S. Then cross multiply this, we get Km into ES equal to ET into S minus ES into S. Now take this to left side. So we get ES into Km plus ES plus S equals ET into S. Now we can take the ES outside. So we get ES equal to Km plus S. We can take the ES outside, then we get ES into Km plus S. That is equal to ET into S, ET into S. Now write this in this way, that is ES by ET, in this form of ES by ET. So this ES and by ET equals this S by Km plus S, that is S by Km plus S. This equation we can take it as 5. Now we have another equation for ES by ET, that is V by Vm equals ES by ET. V by Vm equals ES by ET. Now substitute the value of ES by ET in this equation, in equation 1 from equation 5. So we get V by Vmax equals S by Km plus S. Now we get the equation for V. V equals Vm into S divided by Km plus S. This equation is called Michaelis Menten equation. This equation is called Michaelis Menten equation. Here Km is the measure of the affinity of an enzyme for its substrate. Measure of the affinity of an enzyme for its substrate. Thank you.